Okay guys, welcome to our video on coordinate geometry, specifically the coordinate proof. Okay, the coordinate proof is basically involving placing geometric figures in a coordinate plane. When you use variables to represent the coordinates of a figure in the coordinate proof, the results are true for all figures of that type. So basically we're kind of coming up with a formula instead of always having to use points. So if you look on your paper, you see that you've got two examples, and I want you to go ahead and work those real quick. You can pause it and work those to find your points, and then I will give you the answers. Okay, in the first one, when you're talking about the square, okay, your last point should have been 8, 5. Because remember, if it's a square, all sides are congruent, so the distances between the dots should all be the same, or the coordinates. All right, on the parallelogram, you should have gotten 7, 6. Okay, because remember, in the parallelogram, opposite sides are congruent, and opposite sides are also parallel. So once you found the distance from the bottom, you should have been able to match that to the distance on the top. Okay, so that's just kind of a review. You guys should all know how to do that, just placing the coordinate where it goes. All right, so let's talk about the actual coordinate proof. All right, so here we have a square. First of all, let's look at a square we know are all congruent, right? You know that, so go ahead and mark that. Okay, so whenever you do a coordinate proof, you always start in your corner. It just makes it easier because you're starting at a set location, which is 0, 0, okay? So when you look at your x and y, you know that your x coordinates go left and right and your y coordinates go up and down. So when you're going from A to B, you went A on the x coordinate, so that means that this distance is A. Okay, you have a square, so that means that this distance is also A, this distance is A, and this distance is A because they're all the same. Alright, so to get to B, you had to walk over A units, and then you stayed on the x-axis, so you went 0 units up. So now to go to C, you still had to walk over A units, and then when you traveled up to get to C, you went up A units, okay? And for D, same thing. You started at 0, right, because you didn't go left or right, and then you walked up A units. Okay, so you could check this by getting any square, right? So if you drew a square, and it started at, let's just say, 0, 0, and this next coordinate was, let's say, 6, 0. If you followed the proof, right, you know that the first one was 0, 0, the second one was 6, 0, right? When you traveled up, you should have done 6, 6, and this one should have been 0, 6. Now think about it. Does that make sense? You traveled 6 units to the right, 6 units up, 6 units back, and 6 units down. So you ended up with a square that had congruent sides. You could pick any number of units, and that would work. Okay, so let's do the rectangle. Oh, where did my rectangle go? Okay, so here's our rectangle. Same thing, we know that this side congruent to this side congruent to that side. Okay, so what it means is you are going to start at 0, 0, like I said, right? And when you travel from A to B, you went A distance. So that means that this one is also A. All right, so when you look at your coordinate C right here, you traveled over A because that's your x coordinate, then your y coordinate is B. So that means that you traveled up. That means that this one is also B. So in order to get to A to D, D would have to be 0 and B. So this one would be 0 and B. Okay? And again, if you want to try it, draw a rectangle, make up a point for B and A, and then plug it in and see if it works for you. Okay. All right, parallelogram. Okay, parallelogram, same thing. Congruent, congruent. These two are congruent. Okay, and then you also know that these are parallel and these are parallel. Right, those are just properties of a parallelogram. All right, so again, we start at 0, 0. When it went from A to B, it traveled a distance, so that means that this is the distance of A. Okay, now let's talk about a couple things. Here at D, if you notice its x-coordinate is B. I'm sorry, its y-coordinate is C. So that means that the distance that it travels up is C. So that means that this distance here is also C. Okay? So that means we can look at here and look at our C coordinate. And we know that the y has to be C. Now we just need to figure out what the x is. Alright, and then the D coordinate on your x coordinate, it's actually B. So you walked over B. So this distance right here is B. Right, so that means that this distance has to be congruent to this distance. So this right here is B. Okay, so that means that your x coordinate over here, I'll go ahead and write this, would be A plus B, because we're talking about this whole distance right there. Okay, so this should be your coordinate. Now what I would do on this one too is go ahead and pick a parallelogram, make up some points, and test it and see if it works. Alright. Okay, so the trapezoid. Isosceles trapezoid. So that means that this side is congruent to that side. Okay, so we're looking for C. So let's talk about a couple things. First of all, let's look at the D coordinate. For the x, right, it walked over B, so this distance to here is B. Right, that also means that this distance over here is B, because remember, it's an isosceles trapezoid. Okay, so we know that to get to the C coordinate, the y is going to be C, because it goes up the same amount. Okay, but the entire distance from here to here is A, right? Okay, so from here to here it's A, but we actually only want to get to there. So the x-coordinate, the x-coordinate would actually be A minus B. Okay, so the C coordinate is A minus B and C. Okay, go ahead and try the next page, numbers 1 and 2. Pause the video and then you can come back to see if you got it correct. Okay, so if you look at this, you can notice that this is an equilateral triangle. So this right here is an equilateral triangle. And this inside here is also an equilateral triangle. So you have one big equilateral triangle and 1, 2, 3, 4 small ones. Alright, so, whoops. Here's what you got. You should have gotten for B, should have been h divided by 2 and 3 halves of k, so 1.5k. Your F should have been h over 2 and k over 2. And the other one, D, should have been h k. Okay, so plug those points in if you didn't get it, and then verify to see if I'm right. Okay, and then if you have any questions, you can come and ask me. All right, try the second one. Okay, so this second one, let's look at it. So just by looking at it, you can see that this is congruent to that because they both have the k coordinate. Oh, sorry about that. Alright, so basically you know that this one's congruent to this one's congruent to this one. So this one's actually fairly easy. Okay, so we're looking for B. Alright, so we know that the distance from here to here is k, right, because it goes up k. And then the distance from here to here is negative h, because it's the same as this distance right here. So for b, you should have gotten negative h and k.